Welcome to Brain Vision.
The setup of this problem tells us that we have a hydroxide molecule that is going to make a transition from not vibrating to vibrating a little bit, which I've represented here. So we're going from the n equals 0 state to the n equals 1 state. And the frequency of transition is given by h bar omega. And in this problem, we are also given the masses of our constituent atoms and the energy of the transition, which is 0.463 eV. And the problem is asking for us to calculate the frequency of vibration and the force constant, which is related to that frequency. So if we take a peek at what we want the frequency, but we already have the energy and the constant. So just by rearranging things here, we calculate this to get our frequency, which in terms of just hertz, 7.03 times 10 to the 14 hertz. So it's vibrating at 7.03 times 10 to the 14 times per second. And this is in this terahertz range. But we're also supposed to find the force constant, which, if you look earlier in the chapter, you see that the frequency is related to the force constant by this relation. So frequency is equal to force constant over the reduced mass of the system. And the reduced mass, to refresh your memory, is m1 times m2 over m1 plus m2. And in this case, our reduced mass is going to be 1.02, or sorry, to get the right significant figures, we should say 1.03 times 10 to the minus 27 kilograms. And plugging in for here, well, first let's rearrange so that we get that our spring constant, or our force constant, is equal to omega squared times mr. And if we have omega here and mr here, our force constant is simply to be calculated, and we get 508 kilogram per second square. And that is all that the problem asks for, so we can call it quits.